Today, we are going to completely reframe absolutely everything you thought you knew about a very, very common household supplement. I mean, if you open up your medicine cabinet right now, there's a really good chance you've got a bottle of melatonin sitting right there on the shelf. We all kind of treat it like this natural sleeping pill, right? Just popping a gummy after a long, exhausting flight or tossing and turning in the middle of the night. But what if I told you we have completely, utterly misunderstood what it actually is?
Seriously, think about this. What if the world's absolute most popular sleep supplement isn't actually a sleep drug at all? Today, we're going to explore how this little molecule is far, far more than just a simple sleep aid. It's actually a 2.5 billion-year-old biological conductor for your entire body, literally regulating everything from your immune system all the way to the temperature of your blood. So let's dive in and find out how it really works.
Section 1, More Than a Sleep Aid. Let's redefine melatonin.
Okay, so most of us use melatonin when we're trying to fix terrible jet lag or desperately trying to finally get to sleep, basically treating it like a mild sedative. But biologically speaking, it doesn't actually just knock you out. Instead, melatonin is what scientists call a chronobiotic. You can think of a chronobiotic like your body's master sync cable. It's a chemical signal that synchronizes your internal clock with the external environment. It's not forcing your brain to shut down at all. Rather, it's sending this massive systemic signal telling your entire body, hey, it's biological nighttime. It shifts your metabolism into a nocturnal state, slows down your digestion, and essentially preps your whole system for rest.
Moving on to Section 2, a very bizarre history.
Now, to understand how we got this molecule so wrong for so long, we've got to look at the incredibly bizarre history of the pineal gland, that tiny pine-cone-shaped organ right in the center of your brain that produces it. For centuries, this thing just baffled everyone. Back in the 1600s, the philosopher René Descartes famously declared it the seat of the soul, the one magical point where the mind communicates with the body. Fast forward to 1917, and scientists McCord and Allen made a remarkably weird discovery. When they crushed up cow pineal glands and put them in water, tadpoles swimming in that water literally turned pale. No way, right? It wasn't until way later, in 1958, that a dermatologist named Aaron B. Lerner finally managed to isolate the specific active molecule making that happen.
And what's really fascinating here is the origin of the word itself. Lerner named his newly isolated molecule melatonin. He literally just mashed up melos, the Greek word for dark or black, with tonos, meaning color or suppress. Why? Well, because it suppressed the dark color in amphibian skin. And since he was a dermatologist, he originally crossed his fingers hoping it could be used to cure human skin diseases like vitiligo. So yeah, our famous modern sleep supplement actually started its scientific life as an experimental skin lightening agent for frogs. Crazy, right?
Section 3, the hormone of darkness. Let's look at how it triggers sleep.
So how exactly did a skin-lightening amphibian chemical become known to us as the hormone of darkness? Well, it is all about light. It happens in a few basic steps. Step 1, visible sunlight hits your retina. Step 2, that light alerts your brain's master clock, which is called the suprachiasmatic nucleus, or SCN. Step 3, the SCN immediately hits the brakes on your pineal gland, halting the production of melatonin entirely. And step 4, without that melatonin signal, wakefulness is promoted. You feel alert. But the moment the sun goes down, those brakes are released, the pineal gland just pumps out melatonin unabated straight into your bloodstream, and you start to feel beautifully drowsy.
But how does that drowsiness physically happen to you? It actually comes down to thermoregulation. That's just a fancy term for the process by which your body maintains its core internal temperature. Melatonin doesn't just make your brain feel foggy, it's actually acting as your body's internal sleep thermostat.
When we dig into the thermoregulatory effects, we see that as melatonin levels rise in your blood in the evening, the hormone triggers something called peripheral vasodilation. Basically, it pushes blood away from your core and shoves it out to your extremities. You are literally losing heat through your hands and feet. This actively drops your core body temperature, which is the exact physiological trigger your brain needs to initiate sleep. So when you take melatonin, you aren't just magically getting tired, you are chemically cooling your core down for the night.
Which brings us to Section 4, the ancient cellular bodyguard.
Okay, so here is the absolute biggest plot twist in our explainer today. Melatonin is far, far more than just a sleep thermostat hanging out in your brain. Get this. The melatonin molecule is estimated to be 2.5 billion years old. Evolutionarily speaking, it was found in ancient bacteria, unicellular organisms, and plants way, way before brains, sleep cycles, or pineal glands even existed. It has incredibly ancient origins, originally serving to protect the earliest cells from reactive oxygen species. So to build a completely new, accurate picture of this molecule, we really have to separate pineal melatonin from extrapineal melatonin. Pineal melatonin is what we've been talking about so far. It's produced in the brain, it's highly dependent on light, and it regulates your circadian rhythm and sleep. But extrapineal melatonin, that is totally light independent. It's produced locally in tissues all over your body, functioning as this incredibly potent, localized antioxidant.
All across your body, melatonin is constantly taking on these essential local bodyguard duties. Your gastrointestinal tract produces its own melatonin to regulate gut motility and boost your mucosal immunity. Your skin synthesizes it completely independently to protect against UV damage from the sun. It aids in ovarian follicular maturation in the reproductive system, and it even helps maintain bone homeostasis right inside your bone marrow. In all these extrapineal places, melatonin isn't trying to put cells to sleep, it's acting as an ancient cellular bodyguard, fiercely protecting your cells from oxidative stress.
Finally, let's look at Section 5, the future of chronobiology.
Knowing all of this wild science, how does it actually change the future of medicine? Well, because natural melatonin breaks down super quickly in the human body, its half-life is literally only about 20 to 50 minutes, pharmaceutical companies have stepped in to develop synthetic, targeted melatonin receptor agonists. We're talking about drugs like Remeltion, Tacimeltion, and agomelatine. These precision drugs bind to specific melatonin receptors in your body to do things like treat sleep-onset insomnia, reset the biological clocks of patients who are completely blind, and even treat clinical depression by restoring circadian integrity.
But the future goes way, way beyond just fixing our sleep. Researchers are now actively investigating massive future therapeutic targets for melatonin. We're talking Alzheimer's disease, Parkinson's disease, cardiovascular disease, and metabolic syndrome. Because of its 2.5 billion-year-old role as a cellular protector, scientists actually believe that restoring our natural melatonin rhythms could act as a neuroprotective anti-aging therapy. It could potentially slow down cognitive decline and cellular damage as we get older.
As researcher Russell Rader and his colleagues so perfectly put it in a 2017 paper, melatonin acts as a mitochondria-targeted antioxidant, one of evolution's best ideas. I mean, it is just absolutely incredible to think that the exact same molecule that protects plant seeds from stress and lightens frog skin is also working right at this very moment to protect the mitochondrial powerhouses of your human cells.
Which brings us to our final thought for today's explainer. The very next time you flip off the lights, remember that you aren't just telling your brain to feel tired. You are actively initiating a 2.5 billion-year-old biological symphony that cools your core, protects your gut, and defends your cells. Knowing all of that, how will you respect your own internal clock tonight?
Don't forget to like and subscribe for more How Meets History.